现在
and Philip.
将录制本次会议。
So yeah, so I think before we start, so let me just give it 1 or 2 minutes more for more people to join. Yeah. So can everybody hear me and see me clearly on your side?
Okay, all clear this side, Franco, from Chad.
Ah, okay, thanks, Chad. Okay, so yeah, I think let's start. I don't know if too many people are going to be attending today's session. Today is basically just going to be the migration from analog to DMR and some benefits. From Thursday, we'll start talking more into detail about products, specific functions and features we have on certain models. And then from next week, we'll do Smart One and so on, but I'll go through the agenda as well. So yeah, so let's maybe start. Let me just get this to go to the next slide. So why digital? So a lot of people are still using analog radios out there, and some people are afraid to change to digital because it's new technology. But there is a lot of benefits if we look at digital compared to analog. So one of the key benefits for digital to analog is that you have higher spectrum efficiency, and I'll explain that in detail as well. One of the other advantages on digital to analog is your audio quality, so you don't have any static background noise or any of those type of things. Another advantage for digital is the encryption, where you have end-to-end encryption. I'll explain that also more in details. And then also another advantage for digital to analog is the data applications and some features that you can have on digital which is not available on analog. Okay, so if we look at specifically the Hytera, and most DMR radios out there in the market can support analog and digital. So it means that if you are have a customer that is in the process of looking at digital but still have a lot of analog in the market or in the environment, they can start purchasing digital radios and program them to operate in analog mode. But the radios can also support mixed channel. So if it detects an analog or digital signal, it will then operate in that mode. So all our radios do support that function. So if we look at DMR, which is digital mobile radio in overall, you get what we call tier 1, which is your license-free tier. So it means that it operates on the 446 frequency. You don't need to apply for frequency via ICASA. You just switch the radio on and you can use it. One of the disadvantages on a license-free tier 1 radio is that you sharing that same frequency with other customers. So you might find in some areas where you are using it, you might experience some interference. You also have limited range because the radios are only transmitting 0.5 watts. You're only going to be able to get roughly about between 300 to 500 meters of coverage. So it's very limited in communication distance. But for some customers that don't need to communicate over a far distance, license-free is also a very good option for them. And they don't need to have or apply for frequency from ICASA. The next tier is your tier 2. So tier 2 is where you have to basically apply for a frequency from ICASA, and you can then use a allocated license frequency for your network. You get 2 types of tier 2. So you get DMO, which is direct mode operation, meaning radio to radio in direct mode. So your transmit and your receive is the same frequency. And then you also get RMO, which is repeater mode operation, meaning that your transmit matches to your RX frequency on your repeater, and your transmit on your repeater matches to your RX frequency on your portable. The benefits of a tier 2 system is that you have further communication distance because your radio also would transmit in a higher power. So if it's a VHF, typically a portable radio would Sorry, I was reading a note there. Normally, your VHF radios would transmit at 5 watts transmit power on a portable, and on a UHF radio, typically it's a 4 watt. So you have a lot more transmission power versus a licensed radio. And then the next tier from here is what we call tier 3. So tier 3 is a trunking solution. So it's similar to a tier 2 system, but instead of having a single frequency or single repeater on a site, you have multiple repeaters, and you can support a lot more traffic through that site. So that's what we call tier 3. So tier 1, license free, no ICASA frequency needed. You switch it on, you use it. Tier 2, you have to apply for frequency via ICASA. It can be either a simplex frequency, where it's radio to radio, or a duplex frequency, which is radio to repeater to radio. And then a tier 3 is a trunking solution. I just want to confirm, can everybody hear me and see me? And can you see my screen?
Yes.
Franco, we can hear you. We can see your screen.
Okay. I also want to encourage you guys, if there's any questions as I go through the slides, please stop or interrupt me and ask the questions. I want this for us to be interactive, because I believe that if you want to know something, you can ask me, and we can all benefit from these sessions. Okay, so these are the different tiers. Another thing I also want to highlight is that Hytera, we do offer license-free tier 1 DMR radios. We also cater for tier 2 and also for tier 3. So we have products and solutions for all of these different tiers. Okay, so we also form part of the DMR association. So there's what we call ETSI, which is an international standard. So all the major OEMs follow these ETSI standards. So it means that you can have compatibility where specifically, let's say, if you already invested in a different repeater or a different OEM product, as long as it's an ETSI standard DMR associated product, you can also buy our products and use our products on these systems. So Hytera is associated with the DMR ETSI standards for tier 1, for tier 2, and also for tier 3. So all our products are capable of working on other third-party systems. Okay. Also take note that for DMR tier 2, which is your conventional system, for the ETSI defined, only group call and private call is associated with that standard. So any other applications such as GPS tracking, text messaging, every OEM has their own proprietary way of sending data over the network. But for normal group and private calls, you can use any make of DMR radio, and you'll be able to do those functions. It's just when it comes to tracking and those type of things, it's always best to stay to one OEM's product to benefit the full functions and features that you can get from a DMR system compared to an analog system. Okay. So if we look at existing analog technology and look at how it's being transmitted over the air, normally an analog signal is being transmitted at 12.5 kilohertz. So that's the channel spacing that it uses for it to transmit the transmission. If we had to compare this to other technologies such as Wi-Fi or LTE, so LTE and Wi-Fi is known as broadband communications, where DMR, Tetra, analog radios is known as narrowband technology. So a Wi-Fi network typically would use 20 megabits of bandwidth, where our DMR radios only use 12.5 kilohertz. So to give you guys an example, there's 1,000 kilohertz in 1 megabyte, and there's for Wi-Fi it uses 20 megabytes. So you can imagine how many bandwidth Wi-Fi is using compared to radio technologies. So we only use 12.5 kilohertz channel spacing, so it's very narrow. That's also why the data throughput is very limited, because of it being a narrowband technology. And then for TDMA, which is what we use, TDMA stands for time division multiple access, meaning we're using time to create 2 time slots on that 12.5 kilohertz transmission, which allows for you to be able to have 2 simultaneous transmissions on the same frequency at the same time without the one interfering to the other one. So this is one of the benefits of going from analog to digital, is that you now, instead of having 1 talk path, you now have 2 time slots, which can allow for you to have 2 conversations at the same time through a single repeater. So this is a huge benefit. It's basically 100% upgrade from analog to digital, because now you, on the same frequency, have 2 channels instead of 1. Another benefit also from TDMA from analog to TDMA is that typically on an analog system, when a radio is transmitting, it's transmitting in a continuous transmission. Where in TDMA, it's only transmitting in 30 millisecond bursts, which then allows for you to have that second time slot. And also there's some other features. I'll compare it now to other technologies as well. Okay. So if we look at TDMA versus FDMA, which is a different technology. So FDMA is mostly, there's 3 manufacturers that make FDMA technology. Kenwood is one of them, ICOM, and Kirisan also has some FDMA products. So what FDMA basically does is, it's also a digital system, but instead of using time, they take the 12.5 kilohertz channel space and they split it in half, creating 2 6.25 channels. The disadvantage of FDMA is that you have to double up on infrastructure. So for every frequency or every channel, you have to have a dedicated repeater. So if you guys compare it to TDMA, you only have 1 repeater and it gives you 2 time slots. When FDMA, you have to have a repeater for every channel that you want to have available. You also have to invest in combining equipment. So combining equipment normally is because you have 2 repeaters with 2 transmits, 2 receives, you have to combine this into a single antenna. Where in a TDMA system, you can use existing analog infrastructure. So if, let's say, you already have an analog repeater installed with a duplexer, you can basically just remove the analog repeater, replace it with a Hytera TDMA digital repeater. You don't need to change any of the cabling, the duplexes, all of that can still stay the same. And you then save on not needing to replace existing RF cabling and antennas. Another benefit also, which I want to mention, which TDMA has, which FDMA does not have, or analog, is, let's say if someone is currently, let's say if there's an activity taking place on one of the channels and there's an emergency. Normally, if the channel is busy and you're trying to use your radio, it will not allow you to talk until that channel is available. In TDMA, we have a function called priority interrupt. So priority interrupt will basically interrupt one of those time slots and give priority for you to be able to talk. This is a very handy and good selling point for you to tell to your customers, because in some cases where there's emergencies or people need to press panic buttons, if it was an analog system, they will not be able to report the emergency. Where in a TDMA environment, if you press the panic button, it will have priority over normal group calls, and your emergency will go through the system, and the people that will receive your emergency can react to it. So it's a very nice benefit to have TDMA versus analog or FDMA. Okay, so this just also gives you an illustration of what it looks like if a TDMA radio had to transmit. So let's say if I was transmitting from my radio and I was on slot 1, I will transmit in 30 millisecond increments, and when I'm not transmitting, there's a time gap for a slot 2 for a second group to be able to talk through the repeater. And this is how we are able to achieve 2 calls through a single frequency. Some other benefits also on TDMA is because the radio is not transmitting continuously, you also have battery life improvements. So you can have up to 40% longer battery life from the same capacity battery than what you would have from an analog or an FDMA radio. Okay. Is there any questions anyone has, or can I continue? Okay. Right, so I also mentioned earlier that because if you go from analog to digital, you can also do end-to-end encryption. So this picture here illustrates that, let's say this is me standing here and I'm transmitting, I'm speaking into my radio's microphone. It then goes through a vocoder, which converts the analog audio from my voice into a digital format. It will then encrypt that audio, and then it will transmit it over the network, and then the receiving radio will then need to first decrypt that data before the audio will come out of the speaker. So it's end to end. So if anyone had to listen in onto your frequency, if they don't know your encryption key, they will not be able to listen to the conversations. Is there someone that wanted to ask something? Okay. Okay, so another benefit also to digital is, before I go into the next slide, so when setting up a digital network, there's typically a few things that you need to first do before start programming a system, and that's the fleet mapping. So every radio in the DMR system gets allocated with a radio ID. So a radio ID is like a unique number that's linked to a device. If you use the same radio ID for all your radios, you will lose the private call function. The same for group calls. So in a DMR system, you can have from 1 to 70,000 groups that you can use. So the allocations of IDs that you can use is 1 to 70,000. When it comes to radio IDs, you can use from radio ID 1 up to 16,746,415. Yeah, that's it there. So every radio has to have a unique ID. If you don't use or don't program the radios to have unique IDs, every radio that transmits will show the same ID, same alias. So it's best to plan ahead before programming any system to make sure that you allocate an ID per radio, and that you don't duplicate the same radio IDs for more than one radio. So in a digital system, you're able to do a group call, meaning one to many. This you can already do on analog systems. On analog systems, you would typically use what we call CTCSS tones, which is a continuous tone that you're transmitting on your analog signal. So in DMR, we're using group IDs for you to be able to differentiate different radios to be part of a group. You can also do, like I mentioned, one-to-one calls. You can also do emergency calls, group calls. These are all the alarms that you can also do. So a local alarm is when you're in a distress, you can send a alert call to a specific radio, and that person can then see that you're in trouble or react to you. You can do it to a group as well. And you can also do background voice only, meaning if you press the panic, it will open your microphone and other people will be able to hear what's going on around your radio. And you can do voice with an alarm as well. Okay. Because of the radios being digital, it also supports text messaging. So on the Hytera radios, you can do messages supporting up to 256 characters. You can do a text message from one radio to another radio as a private, and you can also do a text message from one radio to a group of radios. Note that your radio needs to have a display and a keypad for you to be able to send out text messaging. On non-display radios, you can also use the quick message function, where it will then send a quick message from the radio, but you will not be able to receive messages because you don't have a display to be able to read them. Also, let's say if you had to use encryption on your radios, and the radio that's transmitting with an encryption signal, the radio that doesn't have the encryption will not be able to acknowledge or receive any information of that call. It will just show that it's receiving a signal, but you will not be able to hear. Can everybody still hear me? I see we have a power outage here in the office.
Loud and clear, Franco.
Thanks, Jonathan. All right, so yeah, and you can have up to 256-bit encryption. So on the Hytera radios, if you buy it as standard, it can support up to 32-bit encryption. If you want the 256-bit encryption, there's an advanced encryption license that you can purchase, load onto the radio, and it will give you the 256-bit encryption. We haven't had many customers in South Africa requesting the 256-bit encryption, but it is available if there is specific customers that are needing this function. Okay. And it also supports, on some models, you can also have an optional encryption board. So there is some companies out there that do their own encryption. We can share our APIs with them where they can then develop their own third-party encryption as well for our radios. Okay. Another feature on DMR radios is there's a function called man down. So for some of you that don't know, man down is the radio's got a sensor built into it. So if it detects that the radio is tilted at a certain angle and kept there after a certain time, it will then automatically alert the user that it's going to send a emergency. If the person that has the radio with them don't correct it, the radio will automatically send the emergency. So where this is a handy function is especially for some mining customers where they have people that are needing to do inspections and they go by themselves. If they trip or fall or get hurt, the radio will then act as an emergency for them. So for example, like this, the radio is now, sorry, that slide went too quick. So if the radio is tilted like that, after a certain time, it will pre-alert the user. If the user does not correct the radio, it will then automatically send the emergency to a specific group or to a specific person that needs to then react to it. So this is one of the features, and this feature is available on the PD6 series radio and up. But when we go through the actual terminals on Thursday, then I'll discuss all the functions, which radio can support what function. Okay. Another function also is if you are wanting to know if a specific radio is switched on or online, you can do that as well from the radio, where you can do a radio check to see if the radio is online. If the radio is online, I'm still online. Can you guys still hear me?
100% Franco, loud and clear.
Okay, thanks. Sorry, there was another person saying they can't see me. Okay, so oh yeah, okay, yeah. So radio check. So if a radio doesn't report back to the radio that's requesting it, it will then take that the radio is offline. This function can also be programmed into the radio. So if you do a private call from a radio, it will first send a transmit over the network to the radio. If the radio does not respond back to it, it will then display on your radio that the radio is unavailable. So this is also a very nice feature, especially if you are needing to communicate to someone. In analog, you don't know if the person got your message or not, where in this case, the person will see on their display and they'll be able to hear that you called them. Your radio won't transmit if it doesn't get a response that the other radio is online. Okay, so that just explains that. You can also enable and disable radios over the air. You can do it from a display radio, and you can also do it from the smart dispatch software. I'll explain that also more in detail when we go through the models and the smart dispatch. Okay, so you can enable it again if you found it. You can do the alert call. So alert call is if you want to get someone's attention, you can do an alert call from your radio to that radio, and it will then have a tone and a vibrate on the radio for the person to hear and to feel that you're trying to get hold of them. Okay, you can also do a remote monitor. So remote monitor is if you want to listen in on a specific radio, or if you are suspicious of someone that has your radio, you can open the microphone and be able to listen to the surroundings of the radio. This is also a handy feature, especially if there was a person that triggered the emergency and the person's not responding to you, you can then also open the microphone and be able to listen to the surroundings of the person. Okay. Okay, so another function also with our repeaters is that you can program the repeater to operate in a mixed channel. So what mixed channel does is if an analog radio is transmitting into the repeater, it will retransmit that in analog mode. If the repeater receives a signal from a digital radio, it will also then retransmit it in digital. So this is a nice feature, especially for some customers that have still analog radios and have digital radios. Certain groups are using digital, certain groups are using analog. You can use the same repeater. Just note that you can't talk from a digital radio back to an analog radio. But a digital radio can also work as an analog radio. So we have this solution here. So if you need to be able to talk from analog radios to digital radios, you would have to have two repeaters with two different frequencies. You'll then set up your analog repeater to back-to-back to a digital repeater. There is a cable that you can purchase from us, which just plugs into both the repeaters. You configure a few parameters. So if a group talks in the analog system, it will then send that audio over to the digital repeater, and it will then transmit it to the digital radios, and vice versa. If the digital radio had to talk into the digital repeater, it will then send that information to the analog repeater, and it will then transmit out to the analog radios. Okay, so why would you use mixed mode, and when will you use back-to-back? So mixed mode is a feature where if you have certain groups that are digital, certain groups that are analog, and the two groups do not need to talk to each other. And back-to-back is if you have an analog group and a digital group and you want them to be able to communicate to each other, then you would use the back-to-back solution. Okay. So I'm just going to talk about some technologies that's currently available globally. DMR is what we use in our DMR TDMA radios. We also have what we call Tetra, and then you get P25, which is the APCO. It's mostly adopted in America, and then we also have what we call Next Edge or FDMA. So that's the FDMA which I discussed earlier, which is the 6.5 channel. So you'll see if we look at some benefits to TDMA compared to some other technologies. If you look at the coverage, typically from a repeater site to a portable radio, you would normally have between 5 to I've even had some customers say that they can speak 50 or 60 kilometers away from a site, but typically your range in radius from a repeater is up to 75, even some cases 100 kilometers. If we compare that to Tetra, your coverage is a lot less, and the reason being is because you're also transmitting in lower power compared to DMR. And then if we look at FDMA or Next Edge, it's typically the coverage is the same to what you would get from DMR. Okay, so also some more stats that you guys can see. So the initial setup from when you press the PTT until you can talk is typically about 400 milliseconds on a DMR system. Tetra is typically 300 milliseconds, and P25 and FDMA or Next Edge is typically 400 milliseconds. So yeah, so that's the time it takes from when you talk into the radio until the other radio receives your signal. It's about 400 milliseconds. You'll also see the data throughput is very small, so it's 9.6 kilobits per second on a DMR system. Tetra can do up to 28 because you're using also 25 kilohertz channel spacing. And then on a Next Edge system, you only can do up to 4.8 kilobits per second transfer. Just some stats and information. We'll also share this with everyone after these sessions. Backward compatibility. So if we look at the specific topic here, backward compatibility with DMR, you are able to use it on existing analogs technology, and you can also then use it in DMR. Tetra is only Tetra. You can't use a Tetra radio on an analog system. And then a Next Edge radio can also be used on an analog system as well as a Next Edge. And then dispatching capabilities, all of them have the dispatching functionalities. You'll also see something interesting. So there's a function called multipath interference. So multipath interference is, let's say your radio is receiving a signal from the repeater, but the signal is being received from two different directions because the signal might have bounced off a building or from a wall. The radio will automatically correct itself and ignore the signal that's not the strongest signal coming into it. So it does support multipath interference. Tetra radios also support this function, but P25 and FTMA radios don't support multipath interference. Okay. If we look at the cost comparison, so DMR is middle cost. Tetra is actually middle to high. And then P25 is 3 times higher than Tetra, and then NextEdge is also middle cost. So ruggedness, all of them are ruggedized. Coverage for a single site, okay, so like I mentioned before, so 20 to 30 kilometers for a portable. Tetra is typically 5 to 10 kilometers coverage. P25 also 20 to 30, and then NextEdge is also the same. If we compare the cost for a single site, so a DMR site is mid to low, so it depends. If there was existing analog infrastructure, it would be low because you would just have to replace the repeater. If it's for Tetra, it's middle to high because of the infrastructure and processing that's on a Tetra site. P25 is also 5 times more expensive to MPT. And then also NextEdge is also the same as DMR. It can be more also if you need combining equipment. And then the network cost of networking is mid to high for DMR and for Tetra as well. Okay. Sorry. Can everybody still hear me?
Loud and clear.
Okay, so do any of you guys have any questions, anything that you specifically want to ask or want to know in these sessions? Or for me to go back to any of the slides, explain again. Let me just check. I see there's messages coming to my phone. Okay, it doesn't seem like there's any questions. Okay, so I'm just going to go through the agenda for the next 5 weeks. So today we did the migration from analog to digital. This is just the entry into what we're going to be discussing in the next few sessions. So today, most of you already knew the information that I shared, but I thought it would be good for us to do this based on the survey that we done about a month and a half ago. Some people wanted us to talk about analog to digital and some benefits, so that's why we incorporated this. So on Thursday, I'm going to be presenting on the DMR terminals. I'm going to be focusing on specific models, unique features that we have. On Tuesday next week, we'll do smart dispatch. I'm also going to see if I can get a live demo working for you guys as well, so that I can also show you guys a working smart dispatch remotely. I'll also discuss the IP multi-site SIP interface, how you connect it, how you can configure this for a customer. I'll talk about XPT, which is a 2.5 tier 2.5, like a proprietary trunking solution we have. And also I'll talk about the network management NMS software, and XNMS is another software we have similar to NMS. And then I'll do introduction on DMR trunking. So I'll explain all the components that you need in a DMR system. And then from the 2nd of September, Ray will introduce the multi-mode terminals. I'm sure some of you have seen them before, but we'll also do an in-depth on those models. Ray will do an introduction on the Hytera Tetris systems, and we'll do some presentations on body-worn cameras, IDS, which is for digital evidence management software, and we also talk about our POC solutions because we have a few POC solutions. And then on the 16th of September, we'll share some success. So I'll share some case studies with you guys. I see someone is saying, please explain the TDMA again. Okay, I'll go to that now. So yeah, on the 16th of September, we'll share some success stories from some of the projects that we were successful with over the past few years for some dealers that have had great success selling the Hytera products in the market. and what they've basically done. Okay, so someone asked, what is TDMA? So let me explain TDMA. Okay, so sorry, let me just go to that slide. Okay, so TDMA. Let me just see if there's other notes. Okay, so Bosizwe asked me for what's TDMA to FDMA. Okay, so TDMA is what we call time division multiple access, and FDMA is frequency division multiple access. So the differences between the two is that with a TDMA system, we use time to create 2 time slots. So when a radio is transmitting, it would either be transmitting on slot 1 or slot 2. Where on an FDMA system, you're using the 12.5 kilohertz channel, but we're dividing it into 2 6.25 channels. The disadvantages on the FDMA system is that you would need to have 2 repeaters. In a TDMA, you can have 1 repeater and it will give you 2 channels. So I hope that answers Lucy's question. Someone wanted to know up to what tier level is back-to-back supported. Okay, so tier 2, the back-to-back is a conventional, so it's tier 2. So if we look back at this one here, so this is a conventional tier, this is a DMR tier 2 repeater, and this is an analog conventional repeater, and it can only be done this way. You can also interface from an analog or from a digital repeater. You can interface into an airband radio. You just have to create the correct or match the correct pins from the airband or from the midband to the repeater. The repeater itself has a 26-pin connector at the back of the repeater, and if you match those pins to the airband or to a midband, you are able to have communication between the 2 systems using a back-to-back connection, or what we call an E&M connection. Let me just see if there was any other things. Okay, so those are all the questions that were asked there. Is there any other questions or anything anyone else wants to ask? Doesn't seem like there's a lot of questions today. So I'm sure most of you already know this. Here's also my contact details. So if anyone wants to send me anything offline or directly, or have any questions about anything, you can also send me an email. I see we didn't use the full hour that we booked for today. I think with the next session, we might fully utilize the hour. If there's anything you guys want to ask me still, you're welcome to ask me. I'll stay online until 11, or you can send me an email, or you can WhatsApp me or phone me. But if you guys don't have any other questions, then we can finish today's session. So I would like to say thank you to everyone that joined today's session. And from Thursday, we will definitely be going into a lot of more detail on the terminals. So thank you so much, everyone. Thanks, Ian. Stay safe.
Thanks, Franco.
Okay, thanks for that.
Franco, I want to try and connect on the phone quickly. I want to give you a shot of the rack that I put together. I think you might find it interesting. I know
Okay,
Joe
sure.
and Darren are there as well. So give me a moment. I just want to see if I can connect up quickly.
Okay, perfect. Okay.